So welcome Genevieve and Sophia, and welcome Nicholas and Jenilyn and Jordan and Eugene and Jacqueline and Braulio and Brian. So thanks for all coming. Today, I think this will be a shorter webinar than usual. Maybe I shouldn't say that because it might go longer, who knows. But we have fewer things to do than usual because I want to lighten up a bit this week. And we'll see, hopefully you understand why I want to lighten up in terms of the new material. So let me share my desktop and we'll talk about what we're doing today. Okay, so the plan today is I'll start out with questions and answers and a little bit about what's coming up in the next little while. And then we'll talk about the standard normal distribution. So in terms of continuous distributions, we've already talked about the uniform distribution. And I would say on a scale of 1 to 10, on 10 being the most important, I would say uniform is probably about a 3. Any guess on what the normal distribution might be on a scale of 1 to 10? Any guesses? I see one guess. Any others? Yeah, Brian's right. It's a 10. So it is the distribution, not just for this class, but for all of statistics, for the universe. It's everything. So it is the biggie. So we're going to spend most of the rest of the class working with this distribution and distributions that come from this distribution. It turns out almost all distributions that you work with in the real world start as normal and then you do stuff with it. So we'll start out with what's called the standard normal distribution. Then I'll get into the general normal distribution, and then we'll do a lot of examples. So that's the plan today. So let me tell you about upcoming stuff. So first thing is we have the normal distribution, chapter 6. I don't think you're going to find that hard at all. Again, important doesn't mean hard. Important just means it's something that you just have to, you have to remember for the whole class. Whereas the uniform distribution, we're not even going to talk about it again, or almost not, for the rest of the entire course. But normal comes up all the time. So, so we'll do that. Not a hard assignment, I think you'll agree. Including the discussion post is not a tough one either. But the big thing that's happened this week that you're going to spend a lot of time on, any guess? You better all know. Yeah, project 1. Okay, so you should have a lot of progress on project 1 already. I've already noticed a couple hours ago, I took a little break, so I haven't actually had time to read them, but I got 2 emails with project 1 drafts. And my guess is I'll get to those early morning tomorrow. So that's, I try not to do too much late at night because I'm not very useful. So you don't want to have a bunch of wasted readings by me. So tomorrow morning, I'll definitely take a look at them and any others you send me. And I do first come, first serve. So a couple things is that, again, the ones that came in today, I'll be doing probably first thing in the morning. And like this morning, by the way, I don't know if you even, if anyone noticed, first thing in the morning to me this morning, and it wasn't a good thing, was about 2:30, 3 in the morning. I've been up a long time. So first thing in the morning tomorrow will probably be very early too. So I'll get those done before you wake up probably for a lot of you. So if you send them to me, again, first come, first serve. The last possible time to send the draft for me to read through will be Thursday at 8 a.m. But again, if a whole lot of you send it Thursday at 8 a.m., I may not even get to it because there's a lot of you and it takes a long time to read through each draft. That's just a note. It does take me time. It's one of them came in as 19 pages long. That's not going to take 5 minutes. So again, if there's 30 of them, that's a lot of work, a lot of reading, and I only have so much time in my life, even if I don't sleep much. So that's the plan. After that, and after I sit, and by the way, if you sent me your draft, you only get one reading. I read the draft, and then you can ask questions about it, but I don't reread the draft and then reread draft. I'll just read the draft, and then on Sunday or Saturday, even better, soon, you'll be turning it in, and then I'll read it again for the final grade for points, probably Monday and Tuesday and Wednesday and Thursday of next week. So that's my plan for the project. A couple things to note. Don't forget in the project, I haven't read through, but I want to triply emphasize is that throughout the entire project, for every little thing you're looking at, talk about how the client is going to use it and to make a decision. Okay, and that's throughout the entire project, not just at the end. Okay, so that's usually my biggest comment that I make from the draft readings is that, well, how did they, here's the first quartile. What decisions are going to be made after looking at the first quartile, or whatever it might be. Any questions? Any questions on the Project One ideas? Okay, the other thing that was a little concerning for me, are you reading my announcements? Yes or no? Because I've been sending a lot, I sent a lot of announcements out. Okay, the reason I'm worried is that in the announcement that I sent out on, it was like Friday, I think it was, is I let you know that when you were doing the discussion post reply, you must have certain keywords to get full credit. And then I graded them today and I noticed that those words weren't there in most of your discussion post replies. So I'm not sure if you read it or if you just thought I was joking or something. I wasn't joking. So if you're talking about an expected value, you have to have certain words. One word is many, right? Another word is likely. Another word is average. And another pair of words is close to. And I was looking for those words. Okay, you needed to have those. Okay, that was important. Otherwise, it's very hard to get the expected value correct. Okay, so that's just a note. And the reason why I'm specifically concerned about not reading the discussion posts, my announcements, is I sent a really important announcement about the exam. Did you get that? Did you read it? Also about 3 or 4 days ago. And that's a biggie, because if you didn't read it, you could be really screwed. And that is that there were 3 different, we're having a practice exam. I don't know if I put that in the announcement, but the biggie is I gave you 3 different times for you to be available to take it. And you could choose one of the 3. And I said that if you can't make any of them, you need to let me know. Because if you can't make out of it, almost at this point, it's going to get too late where I can't change it. Okay, so let me remind you, let me put, because this is super important, is that the 3 possible times to take the exam are October 14th at 6 p.m. And by the way, that is a Wednesday. Then there's October 15th at 6 p.m. And that is a Thursday. And then there's October 18th at 11 a.m. And that's a Sunday. Okay, you only take the exam once. And what I'm going to do, it's going to look a little weird for you at the beginning, is that you only take it once, and there's 2 others that are going to say you are assigned, but only do one of them. There's no reason to torture yourself. And whatever grade you get on the exam that you take, what I'm going to do is I'm going to go to the other 2 and give you that grade for the other 2, and that's kind of how Canvas works. So that's just a note. So but you take one of them and you have to take one of those 3 times. Okay, there's no flexibility and nobody said they couldn't make it. So I'm assuming everyone can make one of those 3 times. Okay, so you better be able to make them. Any questions at all on, any questions? Okay, today's not the day to go over the exam or to, it's too early right now. We'll do that next week, but I want to make sure that you have it in your calendar. Grab one of those days, put it in your calendar, and don't let anything else get in the way, because you have to take it one of those 3 days. Any questions on that? Okay, and there will be different exams, same difficulty. There isn't an easiest exam or anything like that, but whatever you take, it'll be, slightly different. No, you don't have to reserve a spot to take the exam. You just, I don't know, show up is the right word. I think log on is the right word. Because the exam is at your computer, at your place, home, or whatever that might be. So show up is probably, I wish we could do it where you could show up, but that can't happen. Then we do a proctored exam. It's a whole different thing. But you're gonna have to type everything. Sorry. Yeah, it's a 2-hour exam. So that's a good question. Is there a time limit? And the answer is yes. And by the way, it's October 14th, 6 to 8, October 15th, 6 to 8, or October 18th, 11 to 1 will be the 3 different possibilities. But good question. Any other questions? Any other questions? These are very good questions about the exam. Again, content we're not ready to even go into right now, but in terms of logistics that we can talk about. And all you'll need to bring with you is you'll have a computer and you get a little note card, if you remember.
Professor, in terms of calculators that they're allowed to use, is it strictly the calculators that you provide, or are they also allowed to use
No. Only the ones only the ones on the computer. They'll be embedded in the test itself. Yeah. Okay. So no, you can't use a TI-84 calculator, for example, which is once you get the other one, TI-84 is so much harder.
Okay. I was more referring to like the smaller things, like calculating z-score, arithmetic stuff. Yeah.
That's embedded in Proctorio.
Okay.
Yeah. So there's a button in Proctorio that has an arithmetic calculator. Okay. And the bad news is, I don't even know what it looks like. Only students can see it. Instructors can't. So I don't even know. But there is one, and students have used it. And hopefully it works. I can't even show it to you because I don't have access. Isn't that weird? And Braulio, you won't either. I don't think. Actually, embedded tutors, I don't know whether you're a student or not. You might be the only one that has access. Okay. So is the TI Smart View different from an actual question? I was using a Smart View for the homework and it kept coming out wrong, like 2 or 3 digits. My suggestion is use this calculator. This is what's going to be on your exam. Okay, use this one. The other thing is that the number of decimals is not important. So unlike your homework, or I guess I shouldn't call it homework, your computer graded assignments, it's going to be, I'm going to read it and grade it. Okay, except for the ones that there's some true false multiple choice, but other than that, I'll be reading it and grading it. So I don't care about the 4th decimal place. Okay, that's just not important to me. What's more important is you show your work. Your old school pencil paper to figure out a test. It won't help to have a pencil and paper. It'll end up taking too long. So unfortunately, the problem is you can't get that paper to me without taking a picture of it, but taking a picture of it is not allowed on Proctorio. So it's going to have to be done completely on the computer. But this is an official online class, so I don't feel too bad about that. Yeah, no card double-sided is allowed. And you're going to show that to the webcam. Okay. Any more questions? These are good questions, though. Okay, and if we weren't in time of COVID, we'd have a paper and pencil proctored test, but I can't do that. I'm not allowed to. So it's kind of life right now. Any other questions before we move on? Okay, so let's move on. And I want to talk about the distribution. Okay, and as I mentioned, by the way, when we looked at the uniform distribution, there's really only one main reason that we did that. Do you remember what that was? Because the uniform distribution happens almost never in the real world for continuous distributions. Do you remember the reason? No one knows? No one remembers? It was because we could calculate it. We could actually do the math, and it was an area of a rectangle, which is something you know how to find an area of a rectangle. So what we're going to be doing now is a normal distribution, and I will let you know you can't calculate it nicely. Okay, but the good news is computers can. So what I'm going to show you, and this is going to be important a little bit for the project too, because we've talked about it, at least in my long video, is a picture of the normal distribution, and this is called the standard normal distribution. And kind of a weird thing happened. A few hours ago, I went and prepared for this, and I went online to look for a picture that worked perfect for what we're doing, and it's like took a little while to find one, and then I realized the one I found that looked perfect is mine. It's on my website. It's actually my picture. So this is the standard normal distribution. So I want to note a few things about it. The first is, unlike the uniform distribution, which is just a horizontal line, and a horizontal line has a very nice function, y equals a number. This one is
Alex has something in the stuff.
Not a horizontal line. Question?
Check. Tell him to check to know he's gonna forget about it.
All right, I have a feeling somebody's probably needs to mute themselves. Unless you have a question for me. Check the null, but I don't think that's to me. Okay, so this is the normal distribution. I'm going to say it really fast. Do you know what it means if I say it really fast? The equation? Yeah, you don't need to remember, you'll never use it, but I should say it because I'm the professor. And that is the equation for the standard normal distribution is 1 over the square root of 2 pi times sigma e to the negative 1/2 times x minus mu quantity squared all over sigma squared. So it's evil. It's a very difficult formula, and you never have to even know it. And Braulio, even you wouldn't like it if you had to find the area, because you can't actually integrate it using closed term. Can't even do that. You have to use power series. I'm not doing any of that stuff. So the good news is that we don't have to do any of that. We're going to use a calculator. But I do want you to know a few things, and that's this picture. And that is, for the standard normal, first thing is that the middle of it, and this is symmetric, and when you have a symmetric distribution, the mean and the median are the same. That was something we had a while back. And the mean and the median are both 0. Got it? For the standard normal distribution. And then it looks like so. You can go -1 to 1, -2 to 2, -3 to 3. And 68% about of the area is between -1 and 1. 95% is between -2 and 2. And 99.7% is between -3 and 3. Where have you heard that before? We've talked about this already. And remember, We had a couple rules. Yeah, it's called the empirical rule. So I want to let you know is that when you're doing your project, what you're going to do is you're going to look and say, is my distribution, does it look at least approximately normal? Okay, so does it kind of look like the high points in the center, and does it kind of go down from there? And if it does, then you can use the empirical rule. On the other hand, if it doesn't look normal at all, like if it's skewed left or skewed right, okay, or if it's bimodal, I'm hoping you know what those words mean because those are important for the project, then you can't use the empirical rule. Do you remember what you use, what the word is if you don't have a normal distribution? That the only thing you can use, which is not as good, but it's something you can resort to? Yeah, I won't get on your spelling, but yeah, Chebyshev's. But yeah, that was good. So Chebyshev's theorem. Okay, and that's a little different. It's less powerful, but it's what you have to do if you don't have the normal distribution. It's kind of like plan B. And Chebyshev's always works, it's not as very good. So if you have a normal distribution, 68% of the data is within one standard deviation of the mean, or between z equals -1 to z equals 1. 95% of the data is between -2 and 2. And I want to mention, of these three, we have 99.7 is between -3 and 3. What do you think the most important of these three is going to be? Any guess? This is just a guess. I don't expect you to know why. Good guess, but it's not right. 95% turns out to be the biggie. Okay, so we're going to have like whole chapter dealing with 95%. Okay, and that's on what's called confidence intervals. So I'm kind of giving you a heads up of what's the point of this is that typically you care about the 95%. And that's because if you're 95% kind of sure of it, that's usually enough to move on and say, yeah, that's good enough. Okay, so that's just a big note. Any questions on this? Okay, now what I have is I have a problem to work on that's going to be a little tougher. Okay, let's do the first one. The first one should be really easy. That won't be tougher. What is the probability that if you randomly have something that's a normal distribution, you grab one, but that one is going to be between -1 and 1? The hint is that should be really easy. What's the probability that if you randomly select something, you're between -1 and 1? Okay, good, good. 68%, I like to write it as 0.68 because that's a probability. Probabilities are usually decimals. And when you're doing the online assignment, always read the instructions. If they ask for a percent, give a percent. If they ask for a decimal, give a decimal. Otherwise, it marks you wrong. Okay, when you're taking a test, I'm more flexible. As long as you show your work, I'm good, or your explanation, or your reasoning. But for the online assignments, it's not flexible. Okay, so this was easy. I hope that was easy for you. So that was 0.68. In fact, let me write down probability that -1 is less than z less than 1 is equal to 0.68. Okay, now let's do part B. What's the probability that z is less than 3? So now we're looking at less than 3. That's a little harder. If I said between -3 and 3, I bet you can tell me. What would you say? .997. Got it? But the problem is, it's a little more than that. Any questions on that? So we're going to use the rule of complements. And we want to find out what is the probability that we're not in between -3 and 3. What's the probability we're not between? I think, Nicola, you get the idea, but I think you're off by 1 decimal place. Yeah, 0.003. So just a note, let's write this in. So the probability that -3 is less than x, less than, I should write z, not x, is less than 3. That was equal to 0.997. And the probability that z is an absolute value is greater than 3 is equal to 1 minus 0.997, which is equal to 0.003. Okay, so now what we want is we want the probability that we're less than 3. So the probability that z is less than 3. Well, what we can do is we can say, well, it's the probability that we're between -3 and 3. Plus the probability that we're less than -3. Any questions on that? You can see that from the area, because we want to take everything between -3 and 3 and add on all the stuff less than -3, and that's all the stuff less than 3. Okay, now we have a symmetric picture. We know that if we take the area far left plus the area far right, you get 0.003. What if I want just the area far left? What should I do to that 0.003? If I know the left and the right is 0.003 and I want just the left, what do? Yeah, I half it, divide by 2. So what I get is 0.997 plus 0.003 divided by 2. Anyone lost? Just want to make sure that you're following. And then it's basic calculation work. That is 0.99. So 85. You could use a calculator. I did in my head. Any questions on that? Okay, now let's do part C. Find the probability that z is between -1 and 2. Look at the picture. So between -1 and 2, well, we could say it's between -1 and 1 plus between 1 and 2. Any questions on that idea? All right, between -1 and 1, we've done that already, 0.68. Plus, now we got to find out between 1 and 2. Well, we know between -2 and 2, that's 0.95. We know between -1 and 1, that's 0.68. If I subtract those two, I'm going to get this area here between -2 and -1, and this area between 1 and 2. And that'll be 0.95 minus 0.68. But that gives me 2 of these. So I got to divide by 2. So that's plus 0.95 minus 0.68 divided by 2. Any questions on that? Okay, and I'll leave it to you to do the calculator calculation. Okay, you could do it by hand if you want, because 95 minus 68 and then divide by 2, add it to 68. Okay, the next question is find the value of z so that there's a 2.5% probability of being greater than this value. Any questions on the question? So let's go over here. So we want a 2.5% of being greater than something. Well, if we look, that would be a number such that it's to the right of. But we want to be symmetric. And if you add that to the left of, 2.5 plus 2.5% is 5%. So that means outside of something is 5%. So if outside is 5%, what's inside? What percent? Right, 95%. So then what value of z, what must it be? So there's 2.5% to the right. It's a very easy answer from the picture. Yeah, it's 2. So notice that we're going in reverse now. We're given a percent and we want to find our value instead of given a value and finding a percent. So it's very important to know which direction you're going. So the answer to this one is 2, just from looking at the picture, basically. Okay, find the 16th percentile. Well, to find the 16th percentile. By the way, is the 16th percentile going to be positive or negative? Okay, if it's positive, that means you're like over here somewhere. And that would mean there's 16% to the left. Yeah, it's got to be negative because if there's only 16% to the left, it can't be past 0 because there's 50% to the left of 0. So first thing is going to be negative. So it's going to be negative something. And this is very similar to what we just did. If there's 16% to the left, well, if you go left and right, that's 32%. What's 1 minus 32%? Or 100 minus 32%? 100% minus 32%. Yeah, so what's the answer? What value of z is it? -1. So the answer is -1. It's all by picture. Any questions on that? All right, let's look at F. Find the z-score for the following values. How about 1.3? So who remembers the definition of the z-score, the formula? And the hint is if you don't, you should have it on a note card. You remember?
I could say it. It's probably way easier.
Okay.
So z equals x minus mu
Yep.
over sigma. Sigma or sigma?
Sigma.
Okay, thank you.
Yeah, so it's like ma. And it looks like that. But here's what's interesting. What is mu for the standard normal graph? 0. And sigma is 1. I want to write something down. And this is the first, might be maybe the second time you've seen something like this. And what we can say is that z tilde n 0, 1. And the way you read that is z is normally distributed with mean 0 and standard deviation 1. Okay, So that's when if I ask you to write down the distribution, this is what I ask. This is what I want. I want a tilde, and then if it's normal, I want an n, and then the mean and the standard deviation. So check it out. This is going to be really easy. That's a hint. You won't need a calculator. So let's find the z-score for 1.3. Z equals, well, we work it out. X is 1.3 minus mu is 0 divided by sigma is 1. What's 1.3 minus 0 divided by 1? $1.3. What's the z-score for negative 4.5? Good, negative 4.5. What's the z-score for 2.7? This should get old and boring soon. 2.7? And what's the z-score for negative 1.6? Negative 1.6. So the reason why you use the letter z is because it is a z-score. Any questions on that? Okay, so now the next example is use your calculator. I'm going to show you, we're going to do the calculator from the computer calculator for this problem. Okay, suppose that x follows a normal distribution. Okay, but now the mean is no longer 1 and the standard deviation is no longer 0. Now the mean is 114 and the standard deviation is 23. Okay, find the probability that x is between 100 and 120. All right, so what you're going to do is you're going to go to the calculator. Here's a calculator that will be on the exam, by the way, so get used to it. What number do you think I'm going to use? Which calculator number? There's 25 of them. But I'll let you know we're doing them. I wrote these in the order of at which we do things. So we're not even close to 25 because it's only week 4. So what number do you think you want? So which calculator number? Yeah, number 8, normal probability. I tried to name them in a way that was like logical. Oops, sorry, I hit the wrong one. Try again. There we go. Okay, and I also tried to make it not very hard. Okay, if you use like a calculator, a handheld calculator, it's a lot harder. So the low was 100. The high was 120. The mean was given as 114. And the standard deviation was 23. Any questions on that? Did this look hard? And hopefully, you hit calculate. And by the way, I programmed it so it gives you a whole lot more decimals than you'd ever want. But I don't know, just in case you felt like that many decimals, we can copy and paste. Any questions on that? Okay, how about x greater than 200? So what's the low? What's the low now? Yeah, 200. What's the high? What's the highest number that's greater than 200? Well, you say 201, but I think 202 is bigger than that, and it's also greater than 200. So the idea is there isn't one. Okay, there is no highest number, but this is a computer. Okay, computers aren't like people. So we're going to trick the computer into putting an infinity. And the way you do that, what I strongly recommend is you count the number of digits in all the numbers we've got. We got 114, 23, 200. And then put that many nines plus 2 more nines. So 1, 2, 3, 4, 5 nines. Because we have 3 digits. And if you add 2 more nines, that will always work. We need to erase the p equal because that's what we want it to calculate. And I hit calculate, and there we go. Any questions on that? Okay, let's find the probability that x is less than 90. Okay, what do you think the low is going to be now? How many numbers? My recommendation is 2 more nines than the highest number of digits. And that'll always work, guaranteed. So I put in 5 nines there. What am I going to do for the low? Again, we want less than 90. Yeah, negative 99999, not 0. Because you can have negative numbers with the normal distribution. What's the high? High is easy. 90. And we need to erase the p and calculate. And we get this monstrous number, about 15%. Any questions so far? Okay, find the probability that x is greater than 105, given that x is less than 125. And the hint on this one is that there are a couple posts in the Q&A forum on something similar from the uniform distribution. And I told you what you needed to do. Do you remember what that was? You remember? There was a formula for givens. And that was a probability of A given B is equal to the probability of A and B divided by the probability of B. So we're going to look at the probability of A and B. Well, A and B means that we're greater than 105. And we're less than 125. Okay, divided by the probability of B. And that means x is less than 125. Any questions so far? Okay, so now what I'm going to do is we're going to just 105 to 125. So use a calculator. And let's calculate. And there we go. I don't think I want to keep that many decimals. So that's going to be the numerator, 0.33598. And then I'm going to divide by x is less than 125. So now, if it's less than 125, the high is still 125, but the low now is what? Yeah, negative and a bunch of nines. And you got to erase the p and hit calculate. And you get about, I don't know, 0.683767. Good enough. More decimals than you'd ever want in your life. And I did it this way because now I can just copy and paste this into the Google bar. And it just gives it to you. I'll just grab a bunch of decimals, good enough for me. Any questions on that? Okay, so the next is find the IQR. Do you remember what the IQR is? How that works? Middle 50%, and the formula is Q3 minus Q1. Q3 is the 75th percentile. So where does the 75th percentile go? Which box does that go in? There's 5 boxes. Yeah, that's the P equal 0.75. How about the low? Any ideas? Okay, the low, 75th percentile means less than that value. Well, the smallest number less than that value is negative infinity, so I'm going to keep it as negative 99999. How about the high? Not 2.25. The high is our goal. That's when we leave blank. And let the computer give us the high. And that'll be the 75th percentile, which is this big old number. I'll just grab a bunch of decimals. And then minus. So what must we do to get the 25th percentile? What changes? Yeah, now P is 0.25. And the high should be blank because that's what we want. And there we go. So I can pop that in. I can put that into the just regular calculator. And we get about 31. Any questions? Okay, the z-score for x equals 117, there's not much to do with that one. That's just the formula. You just go z equals, you just take a fraction, you go 117, that's x, minus the mean, and the mean was 114. And then you divide it by the standard deviation. Standard deviation was 23. And I'll let you use a calculator for that. Any questions on any of these kind of calculation problems? Okay, so now it's time to do a word problem. Now we're going to see a real one, and I know there's a few of you, actually a lot of you in the sections that are interested in looking at medical professions, and some of you in business. So I've combined the two. So here is the question. Suppose that the time until you or your wife, if you're male, will give birth. Okay, so if you're a woman, you're pregnant, by the way. And suppose that time is normally distributed with mean 140 days and standard deviation 7 days. By the way, what do they call, what's kind of the words that everyone uses for the mean time to give birth? What do you ask someone who's pregnant? It's a common sentence that everyone would ask. It's not embarrassing or anything. Yeah, what's your due date? My due date's in 140 days. Got it? It turns out that it used to be that the standard deviation was 7 days. Anyone know why medically that's different? The hint is people didn't change. Or you know, a woman's body hasn't changed much. Yeah, C-sections. So we're going to pretend that we're not going to do a C-section or any emergency medical issues. Okay, we're going to let nature do its thing and have the baby. Okay, and then actually the interesting thing, it really is about 7 days. Okay, that is a standard deviation for a birth. Okay, given that there's no C-section. Okay, so now here's the issue. Your boss has just scheduled you or your wife for a business trip to China. We're going to pretend that COVID's over. Okay, I just don't want to go there. Okay, okay, you or your wife leave today and will return in 135 days. Find the probability that your baby will be born in China. How do we do that? So if the baby's born in China, what does that mean? Not quite over 7 days. Has to do with when you're going to be in China. When do you come home? On day, yeah, born before 135. So X is less than 135. And by the way, remember 140 and 7 were the mean and standard deviation. So I can just go to the calculator. So it was 140 for the mean. The standard deviation was 7. The high was 135. You could call the low 0, or you could call the low negative 9999. It turns out you'll get the same answer. I'm going to leave it as negative 9999. And then I need to empty out the probability. And hit calculate. And it's about 0.24. I can go 2 decimals. By the way, would you be okay with that? If there was a 24% chance that your baby was going to be born in China, would you be fine? Okay. Probably not. Okay. If you're a man, you're probably not going to stay married very long, by the way. Not a cool thing to do, to just leave your wife who's having your baby. Okay. And if you're a woman, there's all kinds of issues. Like the kid can't be president if they're born in China, for example. There's lots of problems. Okay. There's medical issues, there's healthcare issues. I'm not going to get into all of it. All right. So that's a bad idea. So here's part B. You're deciding it's too risky. Okay. It's not okay. So you're going to negotiate with your boss to ensure there's no more than a 1% chance the baby will be born in China. Okay, because that might be all right. If there's less than a percent chance, you're going to go for the risk. Okay, if there were a 24% chance, that's too high risk. Okay, you don't want to quit your job, so you're going to figure out, you know, how long do you need well, when do you need to come home? So what day should you ask to be the return date? Any questions on the question? So we want the probability that X is less than some number which we don't know. So I'm just going to call it N for number. We want that to be equal to 1%, which is 0.01. Any questions on how I came up with part B. Okay, so now we can go to the calculator. Where does a 0.01 go? Yeah, this is the P equal. Because we're given the P, which should we leave blank? Yeah, the high. So I'm gonna leave the high blank and hit calculate. So when should you return home? After how many days? $123. Because if it was 124, it'd be slightly more than 1%. And you're trying to negotiate, so you're gonna negotiate so it's slightly less than 1%. So day 123, return home. Any questions on this example? Okay, and by the way, it is true that having a baby naturally is normally distributed. And I told you that normal distribution is the distribution, but we're not going to understand why until next week. Okay, there is a reason why it is the distribution, but next week is the time to find out. All I could tell you is trust me. Sound good? And next week, we're going to have something called the central limit theorem, which is a big theorem that says that everything interesting is normal. Okay, now let's look at problem part C. It is now 138 days later. And the baby still has not been born. Okay, which is okay because you're not due until, if you remember, the due date was 140. Okay, but you're starting to feel it, right? That baby's kicking, right? Find the probability that the baby will be born within the next 24 hours. Any questions on that? What kind of problem is this? It's a good try. It's not an or. Any ideas? Okay, this is a conditional probability because we're given the baby hasn't been born yet. So we want the probability that the baby is born between day 138 and 139. Given that it hasn't been born yet. So X is less than 138. Any questions on that? And that's equal to the probability of both of these being true. Well, if it's in between day 138 and 139, that's right. Given, wait a second, we want to find out, given that it's greater than 138, hasn't been born yet. Sorry about that. So if we want to find out the probability that it's between 138 and 139, and it's greater than 138, that's the same thing as just being between 138 and 139. And then you divide by the probability that X is greater than 138. Any questions on that? Okay, so now let's calculate. Let's do the top, the numerator, 138 to 139. So the low now is 138. The high is 139. We don't know the probability, so that's the blank. And you get about this number. I'll grab a bunch of decimals. 0.055, et cetera, et cetera. Divided by, now we want the probability that we're greater than 138. So that goes from 138 to a bunch of nines. And we want the probability, so the probability is blank. And we get this number. I'll just grab some of them. And let's pop this into a simple arithmetic calculator. And it's about 9%, 0.09. Any questions on that? Any questions? Okay, I have one more word problem example to play around with. It is similar to what we just did. I mean, it'll look different, but it's same ideas. Okay, suppose that the amount of ice cream that you sell each day, so you own an ice cream shop and you sell ice cream, and it's normally distributed with mean 950 ounces, standard deviation 120 ounces. So part A is find the probability that on a randomly selected day, you're selling between 900 and 1,000 ounces. So we want the probability that 900 is less than X is less than 1,000. The mean is 950, standard deviation is 120. So I can go to my calculator. 950 for the mean. Standard deviation is 120. And we want the probability we're between 900 and 1,000. You plug in. And we leave the probability blank. We hit calculate. And about 32% chance. By the way, does this look hard? Have I done anything tricky? Yeah, this my promise was this is one of the easiest weeks there is in terms of new material. But you have a project. So that's what's going to be hard. So we have a light week so you can work on a project. And it's your first project, and some of you have never done a math project. Okay, part B. In the morning, you took stock of your supplies, and you notice that you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? So what does it mean to run out? In terms of probabilities, what are we looking for? So in terms of your shop and your customers, if you run out, what does that mean happened? What does it mean about the demand for your ice cream? High. How high? So for example, if the demand was 1,000 ounces, do you run out? No, that's plenty because you have, how about if the demand was 2,000 ounces, do you run out? Yeah. So in particular, what's the inequality? Probability that X is could say it or put it in the chat box. There's nothing too fancy here. Yeah, greater than 1100. So now we can go to the calculator, and greater than 1100 means the low is 1100. The high is a bunch of nines. And we find the probability. And it's about, I don't know, 11% or so. Okay, and the last one of the day is if you want to be 99% certain that you will not run out of ice cream, how much do you need to have in stock? So the idea is we have to go backwards. The 99% certain that we will not run out. What does that tell us? Which one? Which box? Yeah, P is 0.99. And want to be 99% certain that you won't run out. So to not run out, then which is the one you don't know? The low or the high? Yeah, we don't know the high. So that's blank. And what should the low be? Not 1100, that was the last part. Yeah, negative and a bunch of nines. And we need the stock. If you round up, because you want to be sure as a business person, that would be 1,230. Any questions on this idea? Okay, what I want to give you is the secret word. Okay, my promise, by the way, is this would be shorter than we've had in the past. We've been almost an hour and a half lately, and we're at an hour and 8 minutes or so. The secret word is symmetric, because the normal distribution is a symmetric distribution about its mean. So that's why I chose symmetric. I try to give you something you're not going to guess, but is an important piece. Okay, so I'm going to stop my share and stop the recording.